now that we've seen here in 1.3 some of the the precursors, the why do we use C++, it's important here to take a step back. Now, I know we're taking a step back again before we even get to any code, and we're going to rectify that in just a second. But what you will be doing every time you run a piece of code is doing this process that we see here. It is on page 12, doing this process, figure 1-8, translating C++ source into an executable file. So every time over here, now there is a Replit video, we will be able to see this, and I will go through and I will actually describe, what are you seeing over here in the left-hand column, the middle column, the right-hand column, etc. So we will see Replit again, but this here is just as a demonstration for what happens when we turn source code into an executable file. There's a host of steps, again, that all happen for us silently in the background because all of our modern computers don't have any of these loud moving parts, these slow, loud moving parts that we could actually appreciate what was happening in the background. Here it happens almost instantaneously. So in the middle section here, with main.cpp, a CPP is a C++ file. Main is what we need in order, here in Replit anyway, in order for us to be able to run an executable out of some source code. Now, source code is what you see here in lines 1 through 5. We will get to what all of these mean. It's okay that this just looks like parts of a foreign language plus the two words hello world, and I recognize an exclamation point there. That is perfectly okay at this phase in the proceedings. Right here, all of this that you can see highlighted in blue is source code, and this is the stuff. This is the logic. This is, and I know I said don't do everything top to bottom, left to right, and then I said I was going to say this a million times. In C++ and in all programming languages, we have concrete sequential code for the most part. For us, we're going to start at the top and we're going to work our way from the bottom. And along the way, we are going to work ourselves left to right, mostly exclusively, but we'll talk about math a little bit later. So all of this source code, when I hit run, and you see over there in the right-hand window, it happens very quickly, but it doesn't happen instantaneously. This make-s is going to go through the process we are about to talk to. And the result is right here. On the right-hand side, you can see hello world being displayed. So all of this is part of a process. That process takes what you see here in the middle window and it translates at the very end to what you see over here in the right-hand window. So what's happening behind the scenes? And again, this is on page 12, probably page 12 in your textbook, but for sure it's in section 1.3. First and foremost, we start with the source code. Source code is what you enter into your text editor or your developer's environment. And you can see right here, we have a pretty typical hello world example. We will see that hello world example in chapter 2. So, it'll be familiar to you by then. And right here, you can see that we have the source code as well. So when I hit run over here in my main window, we get the output over here. But really what happens first is the preprocessor runs. Now the preprocessor goes through your source code and it looks for all of these lines over here that start with the pound, the hash, or in C++, on line number 1, right here, character number 1 is called preprocessor. We'll refer to it as the hash or the pound like everybody else does, but technically speaking, it is also called the preprocessor. So this include IO stream, and we'll see it again when we get through, but this is an important component. Without the IO stream, input and output stream, I would not have access to, oh, I don't know, my keyboard. I would not have access to my monitor where I can output hello world over here. So once the preprocessor goes through and it determines what all of those needs are that are included, and you'll notice that it actually has the word include with it right there. We go through and it creates a set of modified source code. Modified source code is not necessarily machine level code. So machine level code actually interacts with your computer, right? It interacts with the monitor, the mouse, the keyboard, the storage, the RAM, the processors, the ALU, the CPU, all of that stuff, zeros and ones. Here at the modified source code level, it is not zeros and ones yet. For the most part, it is still just the source code that you created over here in your, in your application, your developer's environment, but with some slight modifications to it just to help the compiler go along. So that's the next step down here. That is the compiler. What the compiler does is, firstly, it goes through and it checks for any syntax errors. So syntax errors, again, we will see in chapter 2, and they will haunt you for the rest of your developing career, is if you try to use a storage location before it, you have it defined. That's a syntax error sometimes. If you are trying to use a command that you haven't included an include for, those can be syntax errors. At any rate, it will not go through and correct any logic errors for you. And as a matter of fact, if you have any syntax errors, it simply will not complete the compile. Assuming you have not made any mistakes, any egregious mistakes, the compiler will make what is known as object code. Object code is a little closer to machine language, but it is not quite yet machine language. We need the linker for that. What the linker does is it goes through and it identifies where these libraries are located. So the whole idea that, and we use it as a throwaway line right here. It is almost always line number 1 of your code, include IO stream. Hey, let me use my keyboard, my mouse, and my monitor. That would be great. And to you and me as developers, boom, we've got that. Let me tell you, it's not as simple as all that. We need this entire library of functions that enable that to happen at the machine level. We get access to all of that, that pain and suffering that came through many, many years of coding through one simple line, include IO stream right there. The linker goes through and it says, okay, here's all of these C++ libraries. I need this piece, I need this piece, I need this piece, I need this piece. And it starts assembling them into what will be completed as executable code. An executable piece of code from C++ is this little package that does exist as machine level code. So one thing to be aware of here, and it's actually one of the nice things that we can circumvent because we're using Replit as our developer's environment, and it takes care of things like compiling and executing, and that means linking for us too, is if I was to compile this on my computer as an executable, I could put it on my desktop, my Mac desktop. The challenge to that is if I was to hand this to you and you have a PC, that piece of executable code will not work on a machine level with your computer because there's misunderstandings there between what's happening in Mac OS, even how a Mac OS file system is structured versus how a Windows file system is structured. That's machine level stuff. Like, how does this piece of code interact with your hard drive? How does it interact with your RAM to be able to work? How does your computer interact with your monitor to be able to work? All of that stuff happens in the background, and I'm going to go ahead and click this again. So you know what? I'm even going to refresh this page. What we'll do is we'll clear out the it doesn't clear out the text here. I'm going to go ahead and clear out the text, but we have rerun this. We have resecured some space on the server. You can see those down here. We'll talk about these at a later date. And when I hit run, just notice how long it takes in that right hand side. So right under me right here, look how long it takes for, here, I'm going to move. This is good television. So now that I'm in an appropriate spot so you can see everything happening right there above me, when I hit run, look how long it takes for that single line of code to be outputted here. All that is happening in the background in a fraction of a second. So here we go. I'll hit run. And there it was. It didn't take very long, but it wasn't instantaneous either. That's because C++ has to go through the machinations of doing everything that you see here on page 12. Source code through the preprocessor turns into modified source code. Then the modified source code goes through the compiler. Compiling is what happens when we hit run. It goes and it checks for syntax errors, and it starts the process of converting everything to machine level code. From the compiler, we get object code. The object code goes through the linker. The linker goes through and it grabs these other libraries that we need, but we don't have to create. And it goes through and it creates a package of machine level executable code for you and me nearly instantaneously. But in the background, those things are chugging away just as soon as you hit run in your Replit window.